Hey guys, tonight we're going to slow down and listen to a story. A story older than any myth or legend. A quiet epic that flows through everything we know. Close your eyes for a moment and just imagine. Imagine the air you're breathing, the gentle rise and fall of your chest. That breath right now is a part of this ancient story. It's a part of the carbon cycle. The warm blanket wrapped around you, the light from your screen, the very atoms in your bones. They're all characters in this grand continuous play. It's a story so fundamental that if for some strange reason, the universe decided to press a giant reset button and the carbon cycle stopped, well, you probably wouldn't survive long enough to witness the end of the world. It's a sobering thought, isn't it? So, before you get comfortable, take a moment to like the video and subscribe. But only if you genuinely enjoy what I do here. Now, if you're willing to share, I'd be curious to know. Where are you right now? What time is it in your part of the world as we begin this journey together? Let the simple details of your reality ground you, because tonight we're going to travel far and wide through space and time to understand the simple yet profound dance of a single element, the carbon cycle, nature's great balancing act. It's a name that sounds so clinical, so much like a textbook diagram, doesn't it? But what if we saw it differently? What if we saw it as a kind of woven tapestry? A grand slow-motion ballet that connects everything, from the deepest ocean trench to the highest mountain peak, from the smallest bacterium to the tallest redwood. Tonight, our journey begins at the very beginning, or at least the beginning of the story of carbon as we know it. We'll start with the first breath of time. This isn't a story of Earth, not yet. It's a cosmic tale, a story of stars and gas clouds, and the fundamental forces that gave birth to the very atoms that make up our bodies. For an element like carbon to exist, the universe first had to go through a profound transformation. In its infancy, the cosmos was a much simpler place, composed mostly of hydrogen and helium, the two lightest elements. These were the only ingredients the Big Bang could produce in its first few minutes. But life as we know it, with its complex molecules and endless variety, requires heavier elements. Elements like carbon, oxygen, and nitrogen. This brings up one of the great mysteries of cosmology. How did we get from a universe of two simple gases to a universe rich with the building blocks of life? The truth is we don't really know for sure what happened in the very first nanoseconds after the Big Bang. But we have a pretty good theory about the next few 100 million years. After a period of cosmic darkness, the universe began to light up. The first stars were born. Giant fiery furnaces that would serve as the universe's alchemists. Think of a star not just as a giant ball of light and heat, but as a factory, a forge for creation. Within the incredible pressure and heat of a star's core, hydrogen atoms are fused together to create helium. This process, nuclear fusion, is what makes a star shine. But what happens to the helium? In larger stars, once the hydrogen is mostly spent, the star begins to fuse helium into heavier elements. A beautiful, intricate dance of physics takes place. 3 helium nuclei, also known as alpha particles, can come together to form a single carbon nucleus. This specific process is known as the triple alpha process, and it's the cornerstone of our story. Without it, there would be no carbon in the universe, and therefore, no us. This is a strange and beautiful concept. The carbon atoms in your body right now, the atoms in your skin, your blood, the synapses firing in your brain, were not created on Earth. They were forged in the heart of an ancient star that lived, burned brightly, and then died billions of years before our sun was even born. That star, in its final moments, exploded in a supernova, scattering its newly created elements across the vastness of space. It's a powerful idea, isn't it? To think that we are, quite literally, stardust. We are the legacy of a celestial event, so grand it's almost beyond our comprehension. This cosmic inheritance is the first grand chapter of the carbon cycle, a journey that began not in the quiet forests or the deep oceans of our planet, but in the heart of a cosmic furnace. So the stage is set. Carbon atoms born in the belly of a star now drift through the interstellar medium, cold and alone. They are the seeds of worlds yet to come, the promise of life waiting to unfold. Over eons, these atoms, along with other elements forged in stellar explosions, begin to coalesce. Gravity, the silent architect, pulls them together. They form great clouds of gas and dust, nebulae, the stellar nurseries where new suns and planets will be born. Our own solar system, including our home, Earth, emerged from just such a cloud. Our sun ignited, and the remaining material, a spinning disk of gas and dust, began to clump together. The heavier elements, including carbon, gathered close to the center, forming the rocky planets like Earth. The lighter elements drifted further away, forming the gas giants. This is a profound realization. The very makeup of our planet is a reflection of its cosmic origins. The ratio of elements we find here, including carbon, is a direct result of the specific ingredients available in the interstellar cloud from which we were born. It's a kind of celestial fingerprint, a cosmic birth certificate. And the carbon that arrived on Earth's surface was a veteran traveler, having journeyed across light years of space and eons of time to finally find a home here. It was here, in this young, turbulent world, that carbon's grander story, its terrestrial cycle, would truly begin. But the foundation, the very essence of it all, was laid in the death throes of a long-vanished star. We are all, in a sense, children of stars that we will never know. Our very existence a testament to their fleeting, magnificent lives. And yet, this is only the beginning. The carbon that arrived here was in a form we might not recognize. It was not yet part of the intricate dance of life. It was just an element, a single atom among trillions. It arrived on a planet that was, by all accounts, a chaotic and violent place. Volcanoes erupted, meteorites rained down, and the atmosphere was a toxic brew of gases. This raises a fascinating philosophical question. At what point does a simple element, an inert atom, become something more? When does it transition from being a piece of cosmic debris to a building block of consciousness? We'll never know for sure, but we can imagine. We can imagine that first moment, billions of years ago, when the conditions were finally just right for carbon to begin its long, slow journey toward life. It's a journey that required a special kind of patience, a deep geological timescale that is almost impossible for our human minds to grasp. Consider for a moment the sheer improbability of it all. The specific pressures and temperatures inside a star that allowed 3 helium nuclei to collide at precisely the right angle and speed to form a stable carbon nucleus. It's a cosmic fluke, a delicate balance of forces that, if even slightly off, would have meant a universe devoid of life as we know it. Physicists still wonder if there are other processes, other pathways to creating carbon. But for now, the triple alpha process seems to be the one that gave us our beginning. It's a beautiful example of a fundamental scientific principle. The universe, in all its chaotic grandeur, has a way of finding the most elegant and efficient solutions. It's not a conscious process, of course, it's just physics. But it feels at times like a kind of cosmic poetry. So the carbon is here now, on Earth. The next chapter of its story is about to unfold. It will be a story of incredible transformations. It will be a story of immense heat and unimaginable cold, of quiet stillness and violent upheaval. The carbon atoms, once part of a star's fiery heart, now find themselves in a cooler, calmer place. But they are not static. They are in constant motion, ready to react, to bond with other elements, to form the complex molecules that will eventually become the foundation of all living things. Think of them as silent travelers, waiting for their cue to enter the next act of the play. They are in the rocks, in the early oceans, in the primordial atmosphere. They are everywhere, and they are nowhere, patiently waiting for the signal to begin their grand terrestrial dance. One of the lesser-known facts about these early days is just how much of the Earth's original carbon was likely lost. In the early solar system, when the sun was young and very active, there was a period of intense solar wind. This wind, a stream of charged particles, could have stripped away a significant portion of the Earth's original atmosphere, including much of its carbon dioxide. This means that the carbon we see around us today, the carbon that makes up our very bodies, might be a fraction of what was originally here. The rest could be long gone, blown out into the vacuum of space, forever lost to us. This is another one of those beautiful, unresolved mysteries of science. We have theories, we have models, but the full story remains a whisper on the cosmic wind. It reminds us that even when we think we know everything, there is always more to discover, always another layer to peel back. The story of carbon, like the story of the universe itself, is one of constant evolution, and we are just beginning to understand its first few pages. Now, as the planet began to cool, a crucial development took place. The water vapor in the atmosphere condensed, forming the first oceans. And with the oceans came a new stage for the carbon story. Carbon dioxide, a gas, is highly soluble in water. The early oceans began to act as a massive sponge, slowly pulling carbon from the air and into the water. This was the first major step in what would become the terrestrial carbon cycle. The atmospheric carbon, so long a product of cosmic events, was now being influenced by the forces of a living planet. And the oceans, in their vast, quiet depths, would become a repository for this vital element, a great silent vault where a future story could begin to unfold. It's a beautiful image, isn't it? A young planet, wrapped in a blanket of turbulent clouds, the first raindrops falling, and with each drop the beginning of a great and complex chemical process. It's the moment when the cosmic journey of carbon finally meets its earthly purpose. From the fiery heart of a star to the cool embrace of a primordial ocean, the carbon atom has already traveled an unimaginable distance. And yet, its most interesting chapters, the ones that led to us, are still unwritten. We'll explore those next. Our journey continues. A gentle drift from the cosmic to the planetary. We've established that the carbon in your body, the carbon that makes up the chair you're sitting on, and the screen you're looking at, was forged in the hearts of long-dead stars. It was scattered across the cosmos, a celestial dust before being swept up into the swirling nebula that became our solar system. The first breath of time gave us the element. Now, we turn to the stage where it began its great performance, the birth of life. But before the first plants and animals, before even the simplest bacteria, the stage itself had to be set. And that stage was one of immense, constant change. The early Earth was a turbulent world. Volcanic eruptions were constant, spewing not just molten rock but vast plumes of carbon dioxide and other gases into the primordial atmosphere. There were no trees, no grass, no flowers to absorb this CO2. Instead, it built up, forming a dense, heavy atmosphere, trapping heat and making the planet an inhospitable, steaming world. But this very chaos held the seeds of order. The planet's first life forms were not the grand, multicellular creatures we know today. They were microscopic, single-celled organisms, existing in the vast, warm oceans. And among them, a pivotal group emerged, the phytoplankton. We often think of forests as the lungs of the planet. But in the early chapters of Earth's story, the true architects of the atmosphere were these tiny, unassuming organisms floating near the ocean's surface. Think of them as the unseen architects of life. They were the first to truly harness the power of the sun, and in doing so, they initiated a transformation that would change the planet forever. This brings us to a core scientific concept: photosynthesis. We learn about it in school. A simple equation: carbon dioxide plus water, with the help of sunlight, becomes sugar and oxygen. But that simple equation is the most profound biological innovation in the history of our world. It's the process by which living things capture solar energy and use it to rearrange simple carbon atoms and water molecules into complex organic compounds. And the earliest phytoplankton were pioneers of this process. They began to pull the abundant carbon dioxide directly from the seawater, and using the sun's light began to produce their own food. The byproduct of this process was something new and utterly transformative: oxygen. Before the evolution of photosynthesis, the Earth's atmosphere was nearly devoid of free oxygen. It was a world of methane and carbon dioxide, but as these tiny phytoplankton and later cyanobacteria began to proliferate, they started to pump oxygen into the atmosphere. This period, known as the Great Oxygenation Event, was a slow, quiet catastrophe for many of the life forms that had evolved in an anaerobic or oxygen-free world. For them, oxygen was a deadly poison. But for others, it was the key to unlocking new, more energetic forms of life. And for the carbon cycle, it was a game changer. It created a new pathway for carbon to move from the atmosphere into the biosphere. This process highlights a fascinating and sometimes overlooked fact of biology: the intricate relationship between life and its environment. Life didn't just adapt to the Earth as it was. Life actively and profoundly changed the Earth. The air you are breathing right now, so full of life-giving oxygen, is the result of billions of years of photosynthesis by these microscopic architects. It is a testament to the power of tiny things, a reminder that the smallest parts of a system can have the greatest impact. It's a beautiful thought, a kind of biological butterfly effect that started with a single cell and ended with a whole new world. Another remarkable and often forgotten fact about this period is the role of these phytoplankton after they died. They didn't just release oxygen into the atmosphere. They sequestered carbon into the deep ocean. When a phytoplankton died, its body, rich in carbon, would slowly sink to the ocean floor. Over immense stretches of time, layers upon layers of these tiny carbon-rich bodies accumulated at the bottom of the sea, forming thick sediment. This process, a continuous rain of organic material, effectively locked away enormous quantities of carbon from the atmosphere and the surface waters. It's a kind of slow, quiet burial, a long-term storage solution for a planetary scale problem. This deep-sea sedimentation is a crucial long-term part of the carbon cycle that operates on a geological timescale. It's a process so slow and vast that our human minds struggle to comprehend it. A single atom of carbon, once part of a microscopic plankton, might spend millions of years locked away in the rock at the bottom of the ocean before geological forces, volcanic activity, tectonic plate movements bring it back to the surface. This raises a kind of beautiful, unanswerable question. What is the true nature of time for a carbon atom? A day, a year, 1,000 years mean nothing to it. Its existence is measured in eons, in the slow, rhythmic turning of a planet. What kind of a story could such an atom tell, if it could speak? So, while the forests and grasslands would come much later to be the familiar face of the carbon cycle, it's important to remember that the ocean's silent depths and the microscopic life within it laid the groundwork. They were the original engineers, slowly and patiently shaping the world's atmosphere and building a foundation for all the life that would follow. They created a world where multicellular life could thrive, a world of abundant oxygen and a more balanced climate. This is the great paradox of nature. The most powerful world-changing forces can be the smallest and most unassuming. Looking back, we can see this slow but constant process as the Earth's first attempt at a great balancing act. The volcanoes pushed carbon into the air, and the phytoplankton pulled it out, creating a kind of primordial equilibrium. It wasn't a static balance, it was a dynamic one, constantly shifting and evolving. And it was the first evidence of a system that would prove to be remarkably resilient. This system, this intricate dance between geology and biology, between the air and the ocean, laid the groundwork for everything that followed. It reminds us that every breath we take is a connection to this ancient history, a direct link to the microscopic lives that paved the way for our own. Their silent work in the primordial seas is the reason we are here tonight, breathing this oxygen, contemplating this very story. The great balancing act of carbon continued, a slow, patient drama that unfolded over eons. We've moved from the cosmic fires that forged carbon to the microscopic architects in the primordial oceans that began to shape our atmosphere. But for all their silent work, the phytoplankton were just the beginning. The story required a more visible stage and a more familiar actor. And that actor was the forest. The Earth's great lungs. Think about a forest for a moment, not as a collection of trees, but as a single, breathing entity. The air you inhale on a walk through the woods, the earthy smell after a rain, the rustle of leaves in the wind, all of these are manifestations of a vast, biological process. For billions of years, life remained microscopic, confined to the oceans. Then, roughly 470 million years ago, a new chapter began. Life began to colonize the land. And as plants moved from the sea to the shore, they brought with them the ancient technology of photosynthesis, but on a grander, more visible scale. This marked the beginning of a different kind of carbon exchange, a rhythmic breath that has shaped the planet's climate ever since. The process is both simple and profound. Plants, from the tallest redwood to the smallest patch of moss, pull carbon dioxide from the atmosphere. They use the energy from sunlight to break apart the CO2 molecules, taking the carbon to build their trunks, their branches, their leaves, and their roots. This is the very essence of a tree's existence. It is a storehouse of captured sunlight and sequestered carbon. It's an elegant solution to a planetary challenge, a way of transforming an invisible gas into solid matter, into the very structure of life. The world's forests are a crucial part of this exchange. During the day, they are a great inhale, pulling carbon dioxide from the air. At night, or when the leaves fall, the process reverses slightly as the plants respire, releasing some of that carbon back. But the overall effect, over the lifespan of a tree, is to act as a powerful carbon sink. The sheer scale of this process is mind-boggling. The total amount of carbon stored in the world's forests and soils is immense, a quiet green reservoir that helps to regulate the global carbon budget. This brings up a scientific curiosity, a kind of elegant paradox. As a tree grows, it takes in carbon dioxide and releases oxygen. The oxygen you breathe is the waste product of a tree's meal. We are, in a very real sense, breathing the tree's exhalations. And in turn, the carbon dioxide we exhale is a life-giving breath for the tree. It is a beautiful reciprocal relationship, a silent conversation between kingdoms of life. This raises an interesting question. If we, as humans, are the products of this cycle, what does it mean to be a conscious part of a system so much larger than ourselves? What is our responsibility to the very lungs of the planet that give us breath? There is another, more subtle layer to this story, a detail often overlooked. When a tree dies or when its leaves fall, that stored carbon doesn't just vanish. It becomes food for a different kind of life. Fungi, bacteria, and a host of other decomposers take over, breaking down the organic matter. This decomposition process releases some of the carbon back into the atmosphere as CO2, but a significant amount is incorporated into the soil. We'll talk more about soil later, but for now, think of it as a kind of silent partner in the carbon cycle, holding onto a vast reservoir of carbon that has been filtered through the bodies of plants and animals over millennia. The rhythmic nature of this exchange is what gives the carbon cycle its balance. The forests act like a great filter, pulling carbon from the atmosphere, and the decomposition process slowly returns it, ensuring that the cycle continues. It is a slow, methodical pulse. And it is this pulse that has kept our atmosphere in a state of relative stability for millions of years, creating the conditions for complex life, including our own, to evolve and thrive. The carbon atom, once a traveler through the vacuum of space, now finds itself a part of a leaf, a branch, a root, and then, through the quiet work of decomposition, a part of the earth itself once more. Our journey has taken us from the celestial forge to the quiet embrace of the earth's great forests. But for every story told on land, there is a parallel, often unseen, narrative playing out beneath the waves. The vast blue expanse of the ocean is a character in its own right, a colossal and slow-moving force that plays a critical role in the global carbon cycle. It is, in a very real sense, the carbon sink below the waves. Think about the ocean, not just as a body of water, but as a living, breathing reservoir of carbon. It holds an immense amount of the Earth's carbon, far more than the atmosphere and all terrestrial plants combined. The process by which the ocean sequesters this carbon is a combination of physics, chemistry, and biology, all working in a quiet, continuous loop. First, there is the simple, elegant process of dissolution. Carbon dioxide, a gas, dissolves in water. As atmospheric CO2 interacts with the ocean's surface, a certain amount of it is absorbed, forming carbonic acid. This process is a direct transfer, a kind of handshake between the air and the sea. The colder the water, the more CO2 it can absorb. This is a crucial point, and it's why the polar regions, with their frigid waters, act as a massive pump, pulling atmospheric carbon deep into the ocean. The carbon is then carried by great ocean currents, a kind of global conveyor belt, into the deep dark abyss. This is a part of the physical pump of the ocean, a system that works on a planetary scale. But the ocean's work as a carbon sink isn't just a matter of physics and chemistry. It's also deeply biological. Remember our tiny phytoplankton from the last chapter? They are still here, and they are still working. These microscopic organisms, the foundation of the marine food web, absorb carbon dioxide from the surface waters through photosynthesis. They use this carbon to build their bodies and their intricate shells. When they die, they slowly sink, carrying their carbon-rich bodies with them. This process, often called the biological pump, is a continuous, gentle rain of carbon, a silent snowfall of organic matter that drifts from the sunlit surface to the lightless depths. This brings up an incredible, almost unbelievable fact. The deeper you go in the ocean, the colder and denser the water gets, and the slower the currents move. A single carbon atom, having been part of a phytoplankton, might take hundreds or even thousands of years to reach the deep ocean floor. And once it's there, it can be locked away for millennia. Over geological time, the accumulated layers of these microscopic bodies can form vast deposits of chalk and limestone, effectively turning atmospheric carbon into solid rock. This is a long-term, slow-motion storage solution, a testament to the immense power of small things working in concert over vast stretches of time. This also raises a profound question. What happens to the ocean's ability to absorb carbon as its temperature rises? As the surface waters warm, they become less efficient at dissolving CO2. This creates a kind of planetary feedback loop. The more carbon we put in the atmosphere, the warmer the planet gets. The warmer the planet gets, the less the ocean can absorb, leaving even more carbon in the atmosphere, and so on. It's a delicate balance, and we are just beginning to fully understand its complexities. It reminds us that our planet is not just a collection of separate systems, atmosphere, ocean, land, but a single, interconnected whole. A change in one part of the system inevitably ripples through all the others. And then there are the less-known biological players. Think of the great whales. They are not just magnificent creatures, they are also part of the carbon cycle. Whales feed at great depths, where they consume carbon-rich organisms. When they return to the surface to breathe and excrete, their waste fertilizes the surface waters, encouraging the growth of more phytoplankton. This process, often called the whale pump, helps to move nutrients and, by extension, carbon from the deep ocean back to the surface, supporting the very organisms that pull carbon from the atmosphere. It's an example of the intricate and sometimes bizarre connections that exist in the natural world. So, while we often focus on the trees and the plants, it's vital to remember the silent, continuous work of the ocean. It is a slow, methodical giant, breathing in carbon with its currents and its living organisms. It's a part of the planetary story that operates on a timescale far grander than our own, a deep and patient heart that regulates the rhythm of the entire global system. It is a true testament to the power of a fluid, dynamic system, and a reminder that the great balancing act of carbon is not just a terrestrial affair, but a global one, encompassing the air, the land, and the deep, silent sea. We have explored the cosmic origins of carbon, its transformation by microscopic life in the oceans, and its rhythmic dance with the great forests. But the story of carbon doesn't just unfold on the surface of our planet. It goes deeper, into the very core of the Earth itself. A story told in fire and stone. This is the long, slow, and often overlooked chapter we might call the stone heart of the planet. Think about the sheer mass of our world. We live on a thin, fragile crust, a mere skin stretched over a boiling, molten interior. And deep within this interior, carbon is an essential player. The long-term geological cycle of carbon operates on a timescale so vast, it dwarfs the timescales of forests and oceans. This is a story of immense patience where a single atom of carbon can be locked away for millions of years. The journey begins with the carbon that has been sequestered by our phytoplankton and other marine organisms. As these tiny carbon-rich bodies drift to the ocean floor, they form layers of sediment. Over eons, as more and more layers pile on top, the pressure and heat from the Earth's interior increase. This immense pressure slowly transforms the carbon-rich sediment into sedimentary rock, such as limestone. The carbon atom, once a fleeting part of a living organism, is now a permanent part of the planet's geology. It's a powerful illustration of the ancient saying, from dust to dust. But in this case, it's more like, from living thing to solid stone. But the story doesn't end there. The Earth's crust is not a static thing. It is a mosaic of massive tectonic plates, constantly shifting, colliding, and sliding beneath one another. When a plate carrying carbon-rich sedimentary rock subducts, or sinks, beneath another, It carries its carbon cargo deep into the Earth's mantle. The rock melts and the carbon is released, becoming a part of the magma. This process is a kind of geological recycling. The carbon that was once a part of a living thing, then a part of a rock, now finds itself in the superheated pressurized environment of the Earth's interior. This is a crucial and fascinating part of the cycle, because it provides a pathway for the carbon to eventually return to the surface. It is the Earth's own slow-motion breath. The carbon's journey back to the surface is often a dramatic one. It is released through volcanic eruptions, where it is spewed back into the atmosphere as carbon dioxide gas. Think of a volcano not just as a destructive force, but as a kind of planetary pressure valve, a release point for the immense forces and the long-held secrets of the Earth's interior. The CO2 from a single eruption can be immense, a quick burst of what was slowly sequestered over millions of years. This geological part of the carbon cycle is so slow and so powerful that it acts as a kind of planetary thermostat. Over millions of years, if atmospheric CO2 levels drop too low, volcanic activity will slowly replenish it. If they get too high, the process of weathering and sedimentation will work to pull that carbon back out of the air and lock it away in rock. It's a feedback loop on a scale that is almost impossible to imagine. A quiet, continuous conversation between the planet's surface and its molten heart. This brings up a scientific detail that is often glossed over. The speed of these processes is not symmetrical. The carbon can be put into the atmosphere in a burst. A volcanic eruption or, as we'll discuss later, human activity. But the process of weathering and rock formation takes millions of years to pull it back out. This asymmetry is what makes the cycle so fragile when we interfere with it. It's a kind of slow geological ticking clock that we have, in recent times, attempted to speed up. One of the more peculiar and lesser-known examples of this geological process is the existence of what are called carbonatites. These are rare igneous rocks that are not formed from silicates, but from carbonates. They are essentially molten rock made largely of carbon. The fact that an element so associated with life can also form a liquid rock deep within the Earth is a fascinating and beautiful paradox. It reminds us of carbon's dual nature. It is a living element, a builder of life, but it is also a fundamental part of the inanimate geological machinery of our planet. So, as we have seen, carbon's journey is truly a global one, encompassing every part of our world. It is in the air, in the oceans, in the plants, and deep within the stone heart of the planet itself. It's a story of constant motion, of transformation, of a great and patient cycle that has been turning for billions of years. The carbon that was once part of a star now finds itself a part of a mountain, a riverbed, or a distant volcanic island. It is a traveler, a silent witness to all of Earth's history, patiently waiting for its turn to enter the next act of the play. Our journey has taken us through the cosmos, the oceans, and the great geological machinery of our planet. Now, we arrive at a more recent, and in many ways, more poignant chapter of the story. It is a chapter marked by a profound transformation, one that has taken the patient, slow-moving carbon cycle, and in a blink of geological time, has accelerated it beyond recognition. This is the story of a fossil's whispered secret. Think about the coal you might see in a fireplace, or the gasoline you put in your car. These are not just substances, they are frozen moments in time, archives of ancient sunlight. They are the legacy of a different world, a world of vast swamps and giant ferns that lived hundreds of millions of years ago. We know them as fossil fuels. The story begins in a period of Earth's history called the Carboniferous period, which began roughly 360 million years ago. The climate was warm and humid, and the land was covered with dense, lush forests and swamps. The plants in these forests were pulling immense amounts of carbon dioxide from the atmosphere through photosynthesis, just as plants do today. But there was a key difference. At the time, the fungi and bacteria that are so good at decomposing wood and other tough plant matter had not yet fully evolved to break down the lignin in the plants. Lignin is the rigid polymer that gives wood its strength. This meant that when these ancient trees and plants died, they didn't fully decompose. Instead, they were buried under layers of sediment and water, their carbon locked away. Over millions of years, the immense pressure and heat from the Earth's interior transformed this buried plant matter into the fossil fuels we know today: coal, oil, and natural gas. This was a long-term, slow-motion storage of carbon, a kind of planetary savings account. The carbon that was once part of a living tree, a part of the ancient atmosphere, was now held fast in a deep subterranean vault. It was a natural part of the long-term carbon cycle, a slow drain of carbon from the atmosphere and into the Earth's crust. It was a process that took hundreds of millions of years to build up. Then, in a recent flicker of time, something changed. We, as humans, discovered these buried treasures. We began to extract them, and with the invention of the steam engine and the advent of the Industrial Revolution, we began to burn them. The burning of fossil fuels is essentially the process of releasing all that ancient stored carbon back into the atmosphere in a rapid, immense burst. It is a process that is the complete inverse of its creation. What took hundreds of millions of years to sequester, we have released in a mere few centuries. This is the profound transformative impact of their release on the modern carbon cycle. We have, in a very real sense, opened the planetary savings account and are spending it all at once. This rapid release of stored carbon is what is causing the immense buildup of carbon dioxide in our atmosphere. This brings up a critical and often overlooked point. The carbon we are releasing is not new carbon. It is ancient carbon, carbon that was a part of the Earth's atmosphere long before we existed. We are simply returning it at an unnatural and unprecedented speed to its place of origin. This raises a fascinating paradox. The very element that once sustained the ancient world and was then buried in a geological time capsule is now, in its new form as atmospheric CO2, reshaping the modern world. It is the same carbon atom, but its journey has taken an unexpected turn. One of the less-known facts is just how powerful a memory these fossil fuels hold. Scientists can use techniques like carbon dating and isotope analysis to determine the age and origin of the carbon in these fuels, tracing its journey from ancient plant life to modern-day emissions. It's a kind of chemical forensics, a way of listening to the whispers of a world long gone. The truth is, we don't fully know what the long-term consequences of this rapid release will be. We can model it, we can predict, but the Earth is a complex and interconnected system. This raises a philosophical question for us to ponder. In our pursuit of progress and comfort, have we truly understood the profound responsibility that comes with tapping into a planetary cycle that has been in a slow, patient balance for millions of years? We are, in a very real way, writing a new chapter in the carbon story, and we are the main characters. The story of carbon, once a gentle epic of creation and transformation, has now become a fast-paced drama of our own making. We have followed carbon from the cosmic blacksmith to the ancient swamps of Earth, where its journey took a detour into the slow, deep sleep of a fossil. Now, we arrive at the atmosphere, a thin, delicate veil that is the most visible and immediate part of the carbon cycle. This veil is where the story truly becomes one of balance, of a delicate equilibrium that makes our world possible. Think of the Earth not as a cold rock in space, but as a home wrapped in a cozy blanket. That blanket is our atmosphere, and a critical part of that blanket is a specific gas, carbon dioxide. It is the atmosphere's delicate veil. For all its recent notoriety, carbon dioxide is not a villain. It is a critical and life-giving part of the planet's system. Its primary role is to act as a greenhouse gas. This is a core scientific concept, and it's a simple but profound idea. Visible light from the sun, the energy that powers life, passes through the atmosphere and warms the Earth's surface. The Earth then radiates this heat back out as infrared energy. Carbon dioxide and other greenhouse gases in the atmosphere absorb some of this infrared energy, trapping it and preventing it from escaping into space. This is what keeps our planet warm enough to sustain liquid water and, by extension, life as we know it. Without this natural greenhouse effect, Earth would be a frozen, uninhabitable world. Much like Mars, the average temperature would be far below freezing. So carbon dioxide is not just a part of the air we breathe, it is a fundamental part of the planetary thermostat. It is the very reason we are here, a thin blanket that keeps our world habitable. But the balance of this veil is, as the name suggests, delicate. The problem we face now is not the existence of carbon dioxide, but its concentration. When we burn fossil fuels, we are, as we've discussed, adding immense amounts of ancient carbon to this atmospheric blanket. It's like adding an extra layer to a blanket that was already perfectly warm. The result is a planet that is warming at an unprecedented and alarming rate. The balance is being stretched too thin. This brings up a fascinating but sobering fact. The concentration of carbon dioxide in the atmosphere is now higher than it has been in at least 800,000 years, according to ice core data. These ice cores, like a kind of frozen historical record, contain tiny air bubbles from ancient atmospheres, and they tell us a story of remarkable stability for hundreds of thousands of years. A story that only recently took a dramatic turn. This is one of those moments in science where a simple, undeniable fact, a graph showing a hockey stick curve of CO2 concentration, speaks volumes. It is a visual representation of how profoundly we have altered this delicate veil. This raises a fundamental question that we, as a species, must confront. What does it mean to be a species with the power to so profoundly alter a fundamental planetary system? We are not just living on this planet, we are now active and perhaps disruptive participants in its most ancient cycles. We have become a kind of geological force, a new variable in an ancient equation. It's also interesting to consider the sheer scale of the atmosphere. It seems infinite to us, a boundless ocean of air. But in reality, it's incredibly thin. If the Earth were a basketball, the atmosphere would be thinner than a single sheet of paper wrapped around it. It is a fragile, easily influenced part of the system, and that is why the changes we have made have been so rapid and so dramatic. The carbon atom, having survived the immense forces of a star and the long, slow work of geology, now finds itself in a new, fast-paced environment. Its fate tied to the choices of a conscious species. The atmosphere is where the many threads of the carbon cycle, from the breathing of forests to the exhalations of volcanoes, all come together. It is the great mixing chamber, the place where all the planetary breaths, both natural and man-made, mingle and create the climate that defines our world. And it is in this veil that the ultimate fate of so much of the Earth's carbon will be decided. What happens here will determine the future of the oceans, the forests, and the very life they support. We have traveled from the heavens to the atmosphere's delicate veil, a blanket made of a gas. Now we turn our attention to the ground beneath our feet, a world far more complex and alive than it appears. This is the story of the symphony of soil. For all our focus on the grand players in the carbon cycle, the stars, the oceans, the forests, the soil is the quiet, unassuming foundation, a bustling subterranean world where countless organisms decompose and store carbon. Think about a handful of rich, dark earth. It doesn't look like much, but it is one of the largest and most important reservoirs of carbon on the planet. This carbon is not just inert. It is part of a dynamic living system. A vast network of fungi, bacteria, worms, and other organisms live in the soil, constantly working, breaking down organic matter from dead plants and animals. This is a crucial and often overlooked part of the carbon cycle. The process is a kind of gentle, continuous transformation. When a leaf falls from a tree, or a plant dies, its stored carbon becomes a feast for the decomposers in the soil. They break down the complex organic molecules into simpler forms. Some of this carbon is released back into the atmosphere as carbon dioxide through respiration, just as we release it when we breathe. But a significant portion is incorporated into the soil itself, becoming part of the organic matter known as humus. Humus is a dark, nutrient-rich substance that is highly stable and can hold carbon for centuries, or even millennia. It is the long-term, slow-motion storage solution for the terrestrial part of the carbon cycle, a kind of underground vault. This brings up a lesser-known scientific fact. The amount of carbon stored in the world's soils is immense. It holds more carbon than the atmosphere and all the vegetation on Earth combined. This makes the soil a critical and often forgotten player in the global carbon budget. The health of our soils and their ability to store carbon is directly linked to the stability of our climate. When soil is tilled or disturbed through intensive agriculture, this can release the stored carbon back into the atmosphere, a kind of reverse symphony that disrupts the balance. This raises a fascinating and deeply philosophical question. What does it mean to be a good steward of the earth? And how does that responsibility extend to the ground beneath our feet? The health of our soil is not just about growing crops. It is about protecting a vast, living carbon sink, a quiet foundation that supports all life. It reminds us that our relationship with the planet is not just about grand gestures, but about the small, patient choices we make every day. Consider the intricate network of fungi that live in the soil. These mycorrhizal fungi form a symbiotic relationship with plant roots, extending the reach of the plant and helping it to absorb nutrients. In return, the plant provides the fungi with carbon, a portion of the carbon it has pulled from the atmosphere. This is a kind of silent, underground trade, a collaboration between two different kingdoms of life. The soil, in this sense, is not just a passive storage medium. It is a bustling, interconnected marketplace of atoms and energy. The symphony of soil is one of the most beautiful and complex parts of the carbon cycle. It is a slow, methodical dance of life and death, of decomposition and rebirth. The carbon that was once part of a towering tree is now part of a humble worm, and then a part of the soil itself, ready to be taken up by a new plant, and the cycle continues. It is a testament to the idea that nothing in nature is truly lost. It is only transformed, moving from one form to another, in a continuous, quiet ballet. We have journeyed through the cosmic and geological chapters of the carbon cycle, tracing its path from the heart of stars to the deepest layers of Earth. We have seen its dance in the oceans and its patient work in the soil. Now we arrive at a more immediate and, in many ways, more personal chapter: the urban river of carbon. This is the story of how a natural planetary cycle has been profoundly influenced by our man-made world. Think about a modern city. The intricate web of roads, the towering buildings of steel and glass, the constant hum of traffic. These are not just landscapes. They are a manifestation of our collective human impact on the carbon cycle. The river of carbon in our cities is a fast-moving current, a stark contrast to the slow, patient flows of the natural world. It is a human fingerprint on an ancient process. The journey of carbon in our urban environments begins, in many ways, with the release of that ancient fossil fuel carbon we discussed earlier. It is the fuel that powers our cars and trucks, the electricity that lights our homes and businesses, and the energy that heats our buildings. The carbon atoms once locked away in the ancient bodies of trees are now part of the exhaust billowing from tailpipes and the emissions from power plants. It is a rapid one-way flow, a short-circuiting of a cycle that once took millions of years. But the urban river of carbon is not just about combustion. It is also embedded in the very materials of our built world. The concrete that forms our sidewalks and skyscrapers is a crucial part of the story. The production of cement, a key ingredient in concrete, releases immense amounts of carbon dioxide. This process is both chemical and physical. When limestone, a carbon-rich rock, is heated, the carbon is released as CO2. It is a deliberate and significant part of the urban carbon footprint, a kind of geological reverse of the natural rock formation process. This raises a fascinating and often overlooked detail. Concrete, once it is laid, actually begins to reabsorb some of the carbon dioxide from the atmosphere over time, a process called carbonation. It's a slow, quiet process, a kind of ghost of a plant. So the very material we use to build our world, a material that is a major source of carbon emissions, also has a quiet, long-term ability to recapture some of that carbon. It's a kind of subtle, unseen exchange, a testament to the fact that even in our most artificial environments, the natural cycles are still at work. This brings up a beautiful and thought-provoking paradox. We have built a world that is a massive source of carbon, but our ingenuity also allows us to contemplate, and perhaps one day reverse that flow. This is the great challenge of our time. We have become an active, conscious part of the carbon cycle, and our choices now have planetary consequences. This raises an interesting philosophical question. Can we, as a species, learn to design our world in a way that works with, rather than against, the natural cycles? Can the urban river of carbon be redirected, slowed, or even reversed? The carbon in a city is everywhere. It is in the plastic of a discarded bottle, the rubber of a car tire, and the ink on a printed page. It is in the food we eat, the clothes we wear, and the waste we produce. It is a constant flowing presence, a reflection of our consumption-based society. But it is also a source of great innovation. Scientists are working on technologies to capture carbon from industrial sources, to create negative emission buildings, and to develop new materials that are carbon neutral. We are, in a very real sense, attempting to create a new, more sustainable chapter in the urban river of carbon. The story of carbon in our cities is a powerful and humbling one. It reminds us that there is no part of our world that is separate from the natural cycles of the planet. The choices we make, from the car we drive to the materials we build with, all have a ripple effect that extends far beyond our immediate lives. We are not just living on this planet. We are an integral part of its story, and we have a responsibility to tell that story with care and wisdom. Our journey through the carbon cycle has been a study in balance and imbalance, from the cosmic to the personal. We have seen how carbon moves through vast geological timescales, and how our own actions have dramatically sped up that pace. Now, we turn our attention to a more subtle, yet equally profound part of the story, the season's silent pulse. This is the story of a global rhythm, a slow, beautiful migration of atoms across the planet that we can actually see from space. Think about a year, not in terms of months or holidays, but in terms of a single planetary breath. In the northern hemisphere's spring, as the sun begins to warm the land and the days grow longer, a great green wave washes across the continents. Forests awaken, crops are planted, and the land bursts with new growth. All of this new life is pulling carbon dioxide from the atmosphere through photosynthesis. The effect on a global scale is immense. Scientists can measure a noticeable dip in the atmospheric CO2 levels during the northern hemisphere's growing season. It's a kind of planetary inhale, a collective gasp of green. As the northern hemisphere moves into autumn and winter, the process reverses. Leaves fall, plants die, and the decomposition of this organic matter releases the stored carbon back into the air. The concentration of atmospheric CO2 begins to rise again. It's a kind of planetary exhale. This annual rise and fall of CO2 is a beautiful, visible manifestation of the carbon cycle at work. It's a silent pulse, a rhythmic fluctuation that has been happening for millions of years, a reflection of the planet's health and vitality. This brings up a fascinating scientific fact. The northern hemisphere's seasonal pulse is much more pronounced than the southern hemisphere's. Why? Simply because the northern hemisphere has a much larger landmass, and therefore more forests and vegetation. The southern hemisphere, with its vast oceans, has a more muted seasonal rhythm in its terrestrial carbon cycle. This asymmetry is a testament to the powerful role of land-based ecosystems in regulating the planet's atmospheric composition. This silent pulse is a powerful metaphor. It reminds us that the Earth is not a static system. It is alive, it is breathing, and it is in constant motion. And we are a part of that motion. The air you're breathing right now has been part of this seasonal migration. A carbon atom that was part of a leaf in a forest in Canada in the summer might be part of the air you exhale today. It is a profound, constant connection to the global system, a reminder that we are all part of a single, interconnected web. The beauty of this is in its predictability and its scale. Every year, without fail, the planet takes this great, silent breath. The CO2 levels go up and down in a predictable pattern. However, as we've discussed, the overall trend is an upward climb. The seasonal pulse is still there, but it is now riding on a constantly rising wave of carbon. It's a bit like a person who is breathing rhythmically, but whose baseline lung capacity is slowly and steadily diminishing. The rhythm is the same, but the underlying condition is changing. This raises an interesting question. We, as humans, are an incredibly diverse species, with cultures and languages and beliefs that are vastly different. But on a fundamental level, we are all part of the same silent pulse. We all breathe the same air, an air that has traveled across continents and has been filtered by forests and oceans. What does it mean to be a global community? A community that is physically and chemically intertwined with a single planetary system. It reminds us that our shared home is far more important than our differences. We have followed the journey of carbon from its cosmic birth, through the grand rhythms of the planet, and into our own cities. We have seen it as part of stars, rocks, and the very air we breathe. But what about the carbon that is closest to us? The carbon that forms the very basis of our own existence. This is the story of the carbon of consciousness, a philosophical look at the atoms that allow us to contemplate this very cycle. Think about the human body. We are, in a very real sense, walking, talking, carbon-based life forms. Carbon is the fundamental building block of all organic molecules. It is the backbone of our DNA, the structure of our proteins, the energy in our carbohydrates, and the fatty acids in our cell membranes. Without carbon, there would be no US. A human body on average is made up of about 18% carbon by mass. This means that if you weigh 150 pounds, roughly 27 pounds of that is pure carbon. It's a humbling thought, isn't it? To realize that a significant portion of what makes you, you, is an element that was forged in the heart of a star billions of years ago. This brings up a fascinating and beautiful paradox. The same element that forms the inert rock deep in the Earth's crust also forms the intricate living and thinking machine we call the brain. The carbon atoms that make up the neurons in your brain, the atoms that allow you to read these words and understand their meaning, are part of the same global cycle as the carbon in a tree, a volcano, or the deep ocean. This raises a profound philosophical question. At what point does matter become conscious? When does a collection of carbon atoms, arranged in a specific intricate pattern, transition from a simple chemical compound to something that can think, feel, and wonder? The truth is, we don't have a definitive answer. It is one of the great unsolved mysteries of science and philosophy. But we do know that the arrangement of carbon atoms in a brain is what allows for the incredible complexity of thought and memory. The brain is often described as a kind of theater, where different parts play a role in creating the show of consciousness. But at a more fundamental level, it's a network of carbon-based molecules and electrical signals, a testament to the incredible potential of a single element. This also highlights a strange and wonderful scientific fact. The carbon in your body is not static. It is in constant flux. The atoms that are a part of you right now will be replaced over time. The carbon atoms from the food you eat and the air you breathe are constantly being incorporated into your body, and the carbon atoms that were a part of you are constantly being released back into the environment through respiration and waste. You are, in a very real sense, a kind of temporary living eddy in the great river of carbon. You are a unique and transient collection of atoms that have been borrowed from the planetary system. Consider the carbon atoms that are now a part of your own consciousness. They have been on an incredible journey. They were once part of a star, then a cosmic cloud, then a part of the primordial Earth. They might have been part of an ancient phytoplankton, a dinosaur, or a blade of grass. They have witnessed, in their own silent way, the entire history of our planet. And now, for a brief, fleeting moment, they are a part of a conscious being, an organism that can reflect on their very journey. This is a beautiful and humbling thought. We are not separate from the natural world. We are an intricate and temporary part of it. The carbon in our bodies is a direct, undeniable link to everything around us, from the deepest ocean trench to the farthest star. It reminds us that our story is not just our own. It is a part of the grand, continuous epic of the universe. We are the universe, contemplating itself. Our journey through the grand epic of carbon has taken us from the vast and the macro, to the microscopic and the personal. We have followed the element's path from star to human consciousness. Now, we narrow our focus, zooming in on a single beautiful moment, a tiny yet profound part of the cycle, a butterfly's brief journey. This is the story of how the intricate, localized flow of carbon within a single ecosystem highlights the ripple effect of every small action through the larger global cycle. Imagine a single butterfly, perhaps a monarch fluttering from flower to flower in a quiet meadow. This tiny creature seems insignificant in the grand scheme of things, but it is in fact a perfect miniature representation of the carbon cycle at work. The butterfly began its life as a caterpillar. That caterpillar's body was built, molecule by molecule, from the leaves it ate. Those leaves, in turn, were constructed from carbon dioxide pulled from the atmosphere by a plant through photosynthesis. So, the carbon in the caterpillar's body, and later the butterfly's wings, was once a part of the air. It's a direct, undeniable link. The butterfly as it flies is a tiny vessel of this captured carbon. It carries the atoms of a long-dead star, which were once part of the atmosphere, then a plant, and now, for a brief, beautiful moment, are part of a living, flying creature. The butterfly's flight itself is powered by the energy stored in the carbohydrates and fats within its body, all of which are carbon-based compounds. As it flies, it breathes, releasing some of that carbon back into the atmosphere as carbon dioxide. It is a constant, subtle exchange. This small localized journey is a perfect illustration of a core scientific principle: the law of conservation of mass. Carbon atoms are not created or destroyed. They are simply rearranged. The carbon in the butterfly's wing will eventually return to the cycle. When the butterfly dies, its body will be decomposed by bacteria and fungi, and the carbon will be released back into the soil or the atmosphere, ready to begin its next journey. It's a complete, elegant loop, a miniature version of the planetary cycle we have been exploring. This brings up a fascinating, less-known fact about these tiny cycles. The carbon atoms in a butterfly's body might be part of a network that extends far beyond the meadow. A butterfly might fly hundreds or even thousands of miles, carrying its cargo of carbon to a new location, where it might be consumed by a bird, or where its body might decompose, releasing the carbon in a completely different ecosystem. It's a kind of mobile carbon storage system, a tiny traveler connecting distant parts of the world. This is a beautiful example of how every small action has a ripple effect. A single butterfly's journey, in its own small way, contributes to the global flow of carbon. This raises a poignant philosophical question. If the life of a single butterfly is so interconnected with the global system, what does that say about our own lives? We too are temporary vessels of carbon, traveling through space and time. Our own actions, our own breaths, our own lives are a part of a much larger global story. We are not separate from nature. We are an intricate and essential part of its most fundamental cycles. It reminds us that there is a deep and quiet wisdom in even the smallest parts of the natural world, a wisdom that we can only understand if we take the time to truly see and listen. The carbon in a butterfly's wing is a testament to the idea that everything is connected, and every part of the story, no matter how small, is essential. We have journeyed through the patient, slow-moving narrative of the carbon cycle, from the celestial to the minute. But now we arrive at the most critical chapter, one that is still being written. This is the future's unwritten chapter, a time of profound choice and immense responsibility. It is the story of our collective role in steering the future of the carbon cycle and defining our legacy on this planet. For billions of years, the carbon cycle was a grand, impersonal system, a slow and patient conversation between the air, the oceans, the land, and the planet's molten core. Its rhythm was a whisper, its changes measured in eons. Then, in the blink of a geological eye, a new character entered the stage: us. Our mastery of fire and our harnessing of ancient stored solar energy in the form of fossil fuels have given us a power to influence this cycle on a scale that is unprecedented. We have, in effect, become a new geological force. We have taken a slow-moving, deep time process and accelerated it to a human timescale. This raises a profound and at times uncomfortable truth. We are no longer just passive observers of the Earth's systems. We are active participants, and our actions are having a direct, measurable impact. The concentration of carbon dioxide in the atmosphere is a direct reflection of our industrial and technological choices. This is not a matter of debate. It is a fundamental scientific reality, supported by decades of data from ice cores, atmospheric measurements, and climate models. This reality presents us with a choice. Do we continue to write this chapter of the story as a tale of heedless consumption and environmental disruption, or do we begin to write it as a tale of wisdom, ingenuity, and a new kind of partnership with the planet? The truth is, we don't really know for sure what the long-term consequences will be. We have models and predictions, but the Earth's climate system is so complex, so full of interconnected feedback loops, that a certain degree of uncertainty remains. This raises an interesting philosophical point. The fact that there are still mysteries and unanswered questions does not absolve us of our responsibility. In fact, it should compel us to act with an even greater sense of caution and humility. It is one thing to be a new and powerful force. It is another to be a wise and responsible one. This brings us to a beautiful and hopeful part of the story. The same human ingenuity that has led to our current predicament also holds the key to a different future. Scientists and engineers are working on a wide range of solutions, from renewable energy technologies that can power our world without releasing ancient carbon, to innovations in agriculture that can turn soil into a more effective carbon sink, to new materials that can replace carbon-intensive ones. The future's unwritten chapter is not a story of doom. It is a story of choice, It is a collective choice that will define our legacy on this planet. One of the more unique and less known facts about this human impact is the concept of ocean acidification. When the ocean absorbs the excess carbon dioxide from the atmosphere, it makes the water more acidic. This process, in turn, makes it more difficult for a wide range of marine organisms, from microscopic plankton to oysters and coral, to build their shells and skeletons. It is a powerful example of the interconnectedness of the carbon cycle, where a change in the atmosphere has a profound and often unseen ripple effect on the deepest parts of the ocean. It reminds us that our story is not just about the air we breathe. It is about the health of the entire planetary system. The future's unwritten chapter is a story of our relationship with a single element. Will we see carbon as a resource to be exploited, or will we see it for what it is? A fundamental building block of life, a traveler through time and space, a quiet part of the symphony of existence? Our choice will determine the kind of world we leave behind for future generations. It is a collective responsibility, and it begins with a new kind of awareness, a new way of seeing our place in the grand, continuous epic of the universe. We have contemplated the human impact and the choices that lie before us. Now, we prepare for the final turn of our journey, a quiet and reflective moment where we bring the story of carbon full circle. This is the story of the eternal loop, a gentle return. It is a reflection on the cyclical nature of existence and the quiet continuous dance of carbon as it connects all things. From the first moments of cosmic darkness, through the death of a star and the birth of a planet, the carbon atom has been on a constant journey. It has been a part of a celestial furnace, a primordial ocean, a towering tree, and a simple blade of grass. It has been locked away in a rock for millions of years and released in an instant by a volcanic eruption. And for a fleeting moment, it became a part of a conscious being. You. The story of carbon is not a linear one with a beginning and an end. It is a loop, a continuous, elegant dance of transformation. Think about the carbon atoms in your body. They are not new. They are ancient. They have been a part of this endless loop for billions of years. When you exhale, you are releasing carbon dioxide that will be taken up by a plant. When that plant dies, its carbon will be returned to the soil, where it will feed a new generation of life. You are, in a very real sense, a part of a global, continuous breath, a connection to all things past, present, and future. This brings up a beautiful and deeply philosophical idea. There is a kind of immortality in this cycle. The physical matter of our bodies, the very atoms that make us who we are, will not be destroyed. They will simply be rearranged. They will go on to become a part of something else. A tree, a flower, a cloud, the very air itself. The carbon that was once a part of you will become a part of the world, and in that way, a piece of you will continue to exist in the eternal loop. This also highlights a kind of beautiful, less known fact about the universe. It is a closed system in terms of matter. The atoms that exist now are the same atoms that have always existed. They are just in a constant state of flux and transformation. The universe, in all its chaotic grandeur, has a kind of inherent elegance to it, a continuous, unwavering rhythm. This is the ultimate lesson of the carbon cycle. Nothing is truly lost, and everything is connected. We have followed the journey of carbon to the very point of its return. We have seen how it connects the celestial with the terrestrial, the living with the non-living, and the past with the future. The story of carbon is the story of everything. It is a story of balance, of resilience, and of a quiet, continuous dance that has been unfolding for billions of years. And in the final moments of our story, we will bring our awareness back to ourselves, back to our own existence, and to the quiet, peaceful connection we have with this grand, eternal loop. We have traveled a long way together, from the very first moments of the universe to the atoms that allow us to contemplate it. We have followed carbon through cosmic fires, primordial oceans, ancient forests, and the very ground beneath our feet. We have seen it as a part of a slow, patient geological rhythm, and as a fast-paced urban river. The story of carbon is the story of everything, a continuous and elegant loop that connects all things, from the star that died to the consciousness that now reflects upon its journey. The beauty of this is in its simplicity. Carbon is not created or destroyed. It is a traveler, a silent witness to all of time, patiently waiting for its turn to enter the next act of the play. And in this final act, we bring the story back to you. The atoms in your body right now have been on an incredible journey. They were once part of the atmosphere, or a plant, or perhaps an ancient marine creature. They have been a part of this planet's history for billions of years. And now, for a brief, fleeting moment, they are a part of a conscious being. This is the ultimate realization of our journey. We are not separate from the natural world. We are an intricate and essential part of it. The carbon in our bodies is a direct, undeniable link to everything around us, from the deepest ocean trench to the farthest star. It reminds us that our story is not just our own. It is a part of the grand, continuous epic of the universe. We are the universe, contemplating itself. The eternal loop is a story of resilience and transformation. When a tree dies, its carbon is not lost. It is transformed. When a creature breathes its last, its carbon is not gone. It is simply returned to the cycle, ready to begin a new journey. There is a deep and quiet wisdom in this process, a kind of peaceful acceptance of the cycle of life and death. Nothing is truly lost, and everything is connected. The story of carbon is also a story of a silent, continuous dance. A plant takes in carbon from the air, a creature eats the plant, and a new life form is created. When that life form dies, the carbon is returned to the earth, where it can be taken up by a new plant. It is a slow, methodical ballet that has been turning for billions of years, and we are a part of that dance. This brings us to our final moment together. We have reached the end of our journey, and the story of carbon returns to its quiet, continuous rhythm. You have been a part of this story, a temporary collection of atoms that have been borrowed from the planetary system. And now the journey continues, with or without us. The loop will go on. And so we arrive at the end of our story. I'd like to ask you to let all these images and ideas gently fade from your mind. The stars, the oceans, the silent soil, let them all become a whisper, a soft memory. The journey has come to its gentle close, and the great continuous loop of carbon will go on, long after our conversation has ended. I'd like to gently ask one last time, where is the place you're staying now? The time in that place, at this very moment, how is it flowing? Just feel the weight of your own body, the soft surface beneath you, the quiet of the room. Let your awareness return to the very simple act of breathing. Each breath is a part of this ancient story, a quiet, continuous connection to everything around you. As you prepare to drift off, remember that you are a part of this dance, a piece of the cosmos, and that a deep, patient wisdom flows through you. If you found a little peace here tonight, that's all I could ever hope for. Now, let the story fade and the quiet come. Sleep well, my companion, wherever and whenever you are. Sweet dreams.